So my name is Juan Sequeda. I did my undergrad, my bachelor's, and my PhD at the University of Texas in computer science. I graduated in 2008 for my bachelor's, and I graduated in 2015 for my PhD. I arrived at UT as an undergraduate transfer student in 2006. So I did my last 2 years, all my upper division courses at UT. And I was coming in from, my parents were living, we were all living in South America, and then my parents are academics. They moved back to the US, and so I applied to schools, and I got in as a transfer student at UT. And I have to say, I remember as a student, it was just being at UT and knowing that you were taking classes with like the most important people in the world, the people who wrote the books. That was already just amazing. I mean, I remember taking one of the early logic courses with Bob Boyer, and that was just like, this is Bob Boyer, right? And yeah, so it was just truly fascinating to be at a place that is so unique. You're extremely lucky to be there. And one of the great things that I saw was the opportunity to get engaged in research. And I think that's kind of, I was very lucky, kind of my upbringing to be kind of, my parents are scientists, and that's what that came from me. And I just had that opportunity to do it as an undergraduate, which you sometimes don't think about it, right? As an undergraduate, you're going to go do research. I just had a really my experience was, it was kind of by accident that I was already interested in a topic, and that topic was called Semantic Web. It's about how you can make the web smarter and how you can make data available for everybody on the web. And it was a topic around mid 2000s that it was just starting to kind of get some interesting traction. And there was basically nobody at UT starting to do research there, or nobody that I knew apparently. And then literally kind of just, I bumped into somebody who dropped some papers on the ground. I helped them to pick up the papers. I'm like, oh, why are you reading this paper? It's like, well, no, I'm working with this professor. It's like, oh, who's that professor? And it was a professor called Dan Marenker. And I literally just emailed him, and he never responded. And then I went and knocked on his door one day. He didn't respond, and I just kept knocking on his door until he's like, yeah, all right, I see I've signed your emails, and kind of like, who is this guy, right? It's like this young guy, but he really gave me a chance, and he invited me to his research meetings, and we really hit it off. And he basically kind of at that time, he was saying, look, this is 2006, right? There's all this new stuff that you're interested in called semantic web, but there's all this area where he was coming from called relational databases. And this literally was a question that he posed to me right in 2006 is, what is the relationship between these two things, right? This technology, this well-established technology called relational database, and this new technology called semantic web. What is the relationship? Well, what was so interesting is that question that he posed to me early on as a junior became the question that changed my life. I got into the whole topic. So I started as an undergraduate researcher. And I remember that I was out of state tuition, and when I arrived to UT, I needed to get a job related to my degree, 20 hours, right, to get a tuition waiver. And I told Dan, I want to be able to spend time on this, but I can't. I have to have a job. So he got me a job as an undergraduate researcher. And for me, it was just amazing. I'm saying, wait, my tuition is half price. I'm actually getting paid. And then I can substitute some courses for research courses. And I'm like, now my course load is to actually do research and read papers. And when you have to have your writing component, my writing component was not just a course, it was actually research that was going to lead to a paper and to my thesis. I was like, I can't believe this is too good to be true. So that really kind of sparked my interest into research and just seeing all those possibilities. And then I remember the first paper I ever wrote as an undergraduate, I went to present it. The first front row at this was at a workshop at MIT was Tim Berners-Lee. Tim Berners-Lee, who's the guy who created the web, right? He's a Turing Award winner, like Nobel Prize of Computing. So the first talk I ever gave in my life, I was 20 years old. I was right in front to Tim Berners-Lee, and that was something that was just amazing. So I got into undergraduate research from there. And then another cool thing I remember as my undergrad was being kind of connecting the dots and realizing that we have this very important area of computer science because computer science is definitely changing the world. And then I understand this situation about underrepresentation of minorities and how this relates to computer science. So kind of like around 2007, I remember we had this, we met Dr. Richard Tapia, who came to the university, to the department. And I realized that, wait, computer science is changing the world. And if we look at the representation of minorities, of women, of Hispanics, of African Americans, and we actually look at them specifically like in Texas, and we realize, I don't know what, 40% of Texas is Hispanic. Why? And we look at the amount of Hispanics, or even female, right, in computer science, it's not as representative as the demographics. There is a big problem. And the issue of there is that, I mean, because computer science is going to change the world, if we don't have people who look like us and represent us in those positions that change the world, they are not changing the world for everybody. And this is going to be a big problem, which may not be apparent right now, but it will be going forward, especially when we see that in computer science, I mean, the world, and in the US, we're going to have, I think it's what, by 2050, 30% of the population is going to be Hispanic. But if we don't have leaders by that time who are also Hispanic, who represent that, it's going to be a big problem. So that was really kind of interesting to realize the current situation, and we have to do something about it. So we started this group called ELA, the Empowering Leadership Alliance, to kind of bring together underrepresented minorities within computer science. And that's really cool to see how that has, over 10 years now, has expanded and continues to be strong in the department. So yeah, so that was kind of getting into my undergraduate degree. Now, I remember I was going to graduate, and at that time I was like, well, I like this research stuff, but I could also go get a job. So what should I do? So I did apply. I remember applying for jobs, and it was just so cool to go to the recruiting sessions, and everybody wants to hire computer scientists. Everybody wants to go hire computer scientists. So you could really, it was so easy to get a job. Basically, people were throwing jobs at you because we are the best, right? People come out of UT computer science are the top of the top of the top. But at the end, for me, it was, I really loved this research that I was doing. And so I applied to the PhD program, but I didn't want to go get a PhD. I really wanted to work on this particular problem that I was already working on. I wanted to continue working with my advisor, Dan Moranker. I wanted to stay in Austin. And the funny thing is that I wanted to start a company. I've always kind of been very entrepreneur. I like that. And my idea was, oh, if I do a PhD, that kind of helps me, it can help me start a company. And I remember Dan telling me once, saying, wait, so why do you want to get a PhD? I told him, well, I want to go start a company. He's like, well, you don't need a PhD to start a company. I was like, that's true. But if you do a PhD, you're really focusing on a problem that's really, really hard. And if you kind of tie that hard problem that nobody has solved before to the industry, maybe that's an opportunity to start a company. Now, I'll be very honest. I wasn't the smartest person in the group always. I mean, I did not have the 4.9 GPA that people have applying. My GPA was not to those standards. So I was kind of in a really wiggle situation that I didn't know if I could get in. But I really am glad I got the opportunity to show that I had the opportunity, to be part of the program, and the department trusted and believed in me. From there, I did get accepted to the PhD, and I only wanted to get a PhD because I wanted to work with Dan and work on this research and stay at UT. And it was the best decision of my life. 7 years, which, if you know, is kind of a very long time to be in school after 5 years. Actually, a computer science PhD in the US is on average 7 years, so I finished it on average. But going into grad school and getting my PhD was the best time of my life. I tell people I learned two things in my PhD. One is to be comfortable in a sea of ambiguity, that you really get trained to be able to manage situations that are not well defined, that you can be told, go figure this out, blah. And what does blah mean? I don't know, you go figure it out. And then once you go figure it out, you kind of understand what's going on, and then you can kind of organize things. And then later on, you see what the situation is. And then the next thing, which is what I learned, is to communicate. It's how to take something that was very ambiguous and be able to explain it to other people so they can understand it. And at this moment, what you really want is to be able to communicate in two ways: written, how to write papers, right? And orally, right? How to talk to people, how to write, how to make presentations. And those are the two types of communications which are key. Later on, you'll solve the problem. Later on, you're pretty clever and smart, and you'll come up with a very unique, novel solution to a problem. But before you actually get to the problem solving, I want to be comfortable in the sea of ambiguity, and I want to be able to communicate.
Is that something you learned during the course of your college, or were you encouraged to take any particular classes about that, or did you just kind of figure that out on your own?
Definitely not on my own. That is part of I mean, that's in the research environment. So with the professors, with your people who are teaching you, when you're writing, when you think about it, people kind of complain about writing papers and stuff like that. Truly what you're trying to do is practicing your communication skills, because you could be the most smartest person in the world with the brightest idea and the brightest solution. And you may have the solution to solve a problem that nobody's been able to solve before. But if you can't explain that to other people,
yes,
it gets lost. It just stays in your mind. So being just the brilliant person is not sufficient. You need to be able to be able to communicate. And this is just practice, right? When you take classes about writing, about reading and trying to explain it to other people, that's just part of it. I mean, I can tell you, working with Dan, the amount of papers and stuff that he would rewrite for me originally, and the amount of red marks that I would see over place, that was just normal at the beginning. And you just start little by little getting better and faster. You find out, you come up with the techniques to kind of write better and think about organizing your thoughts. And this is just kind of practice makes perfect, and you'll never be perfect about it.
Did any of the student organizations help with those kinds of skills?
That's a good question. I think the good thing about the student organizations is that you're able to have that that network of peers like you. And I think it is intimidating to communicate, right? And talk to other people, talk in front of an audience of people who you don't know. But being in a student group in a particular community, you are identifying with people who feel like you, who are like you, and you feel more comfortable. And that's a great place where you can practice and present things. And you say, hey, I need to go give a presentation. Can you just listen out to me, listen to what I'm going to say, and give me your feedback, right? So that's really important. Why you want to be able to create that network, and being part of student organizations is really crucial. In a nutshell, what my research and what my PhD was, taking all the amount of data that's in relational databases. So that's where the majority of the world's data is stored, in relational databases. It's just, imagine data stored in tables, right? You have tables and columns. But there is this new kind of model of data, which is graph data. So just imagine what you call nodes and edges. You have a bubble, a line, a bubble, and so forth. So what my research was, understanding the relationship of taking data that is represented in tables and how to translate that into data in graphs. And then there was all these theoretical questions about, how do I know that is a correct translation? How do I know that it's the best translation? What does correct actually even mean? And then in the inverse way, I want to say, hey, I have questions that are in terms of a graph. So for example, you think about Facebook, right? All our social networks, these are graphs, and you can ask a lot of graph questions, and you can say, hey, like how do I get from one place to another place following all these edges and stuff? And how can I take questions that are in terms of graphs and translate that back into questions in terms of tables? And so those translations from tables to graph and from graph to tables was something that was not well understood. People had been working on this, but it was done kind of in a very ad hoc, hackish, in a very hackish point of view. And we looked at this problem from a very theoretical point of view, and then actually built systems about it. And what was really cool is that you take the theory and you take the practice, and you combine these two things, and it matches. And that's the really beauty of computer science, I think, is that the theory explains the practice, and the practice also explains the theory, both ways.
What kind of coursework was involved?
Yeah, so it does. So it's a lot of math, so more logic and theory, and a lot of systems types of courses. So so for the theory parts was all the like discrete math something you have to completely, it's one of the bases, all the types of logic. So when you look at artificial intelligence, AI, this is the part of the knowledge representation and reasoning part of logic, of artificial intelligence. So being able to understand all of that. So first order logic is a completely crucial aspect. Why? Because you can represent tables and queries over tables and graphs and queries over graphs in first order logic. So you want to be able to understand that. And then also it's the systems part. So I want to be able to understand databases. I want to be able to understand systems that manage data at scale. So taking all those systems courses are crucial. So it is a combination of systems and also a combination of the theory. So so courses on both are fundamental to be able to go do at least the research that I was doing. Throughout my PhD, kind of towards the PhD, Dan and I were really excited about the research, and we wanted to go take this to the next level, which was, okay, we do theory and practice in our research, but kind of the ultimate impact is, let's take what we've done kind of in the lab and let's put it out to the real world. And we really thought that there was an opportunity to go build a company, literally have a startup. And why? Because at this time, people are starting to get interested in graphs, and they're like, oh, graphs are the latest, coolest thing, and we want to be able to do things with graphs. But my data is in all these relational databases like Oracle or Microsoft SQL Server. So how do I put this graph technology on top of my databases? And we had a solution for it. And we had the science behind it, and we wrote patents about it and everything. So we started a company out of that, and it really started to kind of boom. Like we grew the company over a couple of years. We were like 12 people. We had a lot of, we actually got funding, but at the end we were making money from our customers. And so we were doing that for several years. And so that is so cool to see something that you have done in your research. You really started from kind of nothing, in the sense that there was something that we didn't understand, and now we understand it, and other people find it valuable and they're willing to go pay for it. That's really cool. I mean, that's truly kind of how you would define impact. So we were doing that. And then actually one of our customers, one of our users, was actually a company here in town called data.world. And we've known them for a while, and they actually, we actually thought, hey, we should do something together, and they became our customer. But then very quickly they realized, wait, that technology you guys have, that's really important for what we're doing. And a year ago, they acquired us. And I think that was another super awesome accomplishment that you feel is like, yeah, you started from nothing, you build the research, you go build the product, people find it valuable, and then people find it so valuable that they want to buy the whole thing. And that's where I am right now. So right now I am the principal scientist at data.world. It's a company here in Austin. And I carry multiple hats. So technically carry two hats. One of my hats is I still carry my scientific academic hat, where I strive to be able to take problems that we see in the real world and figure out, hey, these are interesting problems that there's some research in here still. And let's go figure out how to go solve these problems. And I work a lot with kind of our research partners, other universities who want to be able, who are interested in those same problems that we have. And I'm saying, hey, how about you guys work on these problems, and then we can work together. And when you're ready for a solution, we actually have a place where you can try them out and test them. So that's kind of in my research hat on. But I also carry my kind of my sales business hat on, which during the startup, I had to do a lot of selling. And that's where the communication would come in key, right? You have to be able to communicate to go sell. So I help a lot in the sales process too. So we want to be able to go talk to a customer and tell them why our product is different and unique and better than our competition, and speak to the value that it provides, and then go into more of the technical aspects about it. That's the type of work that I go do. So I spend a lot of time talking to customers on the business side, and then translate kind of the technical features that we have to the value that it provides to the customer. And then I'm on the engineering science side, where we're able to still do research.
I know you travel quite extensively. Can you tell us some about all the wonderful places you've been to?
Yeah, so my travel is probably just half and half for the conferences on the academic science side, and the other half for the business side. So yeah, I mean, last year I think I went to Europe 7 times, probably. I don't know. I've been with a lot of either summer customers, but a lot of is also research partnerships. And here in the US, all over the country, to go visit customers. I mean, California, New York, Minnesota. I mean, yeah, all over the country. I mean, I love to travel. It's great because you get to go meet with so many people. So when I go to conferences to go present work that we've done. Luckily, last year our big conference was in New Zealand, so it was in Auckland, and to go in and present the result of research that we had done in the company. And it was actually, you're now combining the academic side with the business side together. And that's really, really cool, where you can put these two things, you want to combine them. So yeah, so for example, today, I've had meetings with a PhD student that I'm supervising. I've been on calls with business folks on some customer calls, some engineering calls on kind of a new product, new features that we're going to be developing. That's a normal day for me. And after this call later today, I have to go review a paper because I'm on editorial boards of journals. And I'm lucky that I've been able to get a training to be able to feel comfortable in different positions. So I could go and be like the people person and go talk to the sales folks, but I can be a geek and go talk about engineering, but also go talk about theory with theoreticians that I'm working on, and tie all these threads together.
Outside of your work, what do you do for fun?
Well, traveling is part of the fun that I get to do. That's one of the big things. I love to cook. That's something, and now I'm doing it way, way more, and I love it. Like breakfast, lunch, and dinner are things that I cook a lot. So I love to cook. I love to go, and people will get annoyed going grocery shopping, but no, I love it because I think about when I'm going to go cook. That's one thing. I love to dance. I'm a salsa dancer. I grew up dancing salsa a lot. Something that I miss a lot. I can dance with my wife here at home, but that's it right now.
What you're doing right now, is this going to fulfill you for the next 10 years, or are there other research interests that you're seeing over on the side that you think, oh, that could be fun too?
So I think both. So for me, I have my personal career aspiration is a cycle. And it's a cycle that starts from a basic research question. And when I mean it's a basic research question, it's that the theory folks will understand it. But when you go talk about it to people in industry, they're like, what the heck are you talking about? Like, that's gibberish. I don't know what you're doing. But I feel that I'm going to find something that down the line, probably a couple of years later, those industry folks are going to say, hey, I have this problem. And I'm like, hey, remember that thing that you said a couple of years ago that you had no idea what it was? Well, guess what? That's the solution to your problem. And then you go into this phase of kind of convincing them and learning more from them to make sure it truly is. And then you realize, okay, it is. And that's something I can actually commercialize. I can actually sell, and I can actually go do a business about it. And then you go into this cycle of, all right, let's go do a business out of it. And then the business, you want to be successful, saying I want to be able to go sell more of these things. And in that process, you start finding new problems because you start talking to new people, and then you start getting exposed to new things. And the goal is to then, when you close that cycle, is to find a new problem. that starts that cycle again from a basic research. And I feel that I'm finishing this one cycle right now. And for me, that is going to be around 10 years, right? So I literally started kind of the core of my research around 2009, 10, right? We're at nearly a decade to be able to do that. And I feel that I want to go do that again. I feel that I've kind of matured and learned more, and probably not going to take me 10 years. All right. But hopefully not. Well, I don't know, but it's science, right? That's the thing, is that when it's science, you don't know. So, and that's something that we're doing here within the company. So I have the liberty to go find interesting problems that I can say, hey, here are problems that our customers are not going to care about right now, but I'm going to bet that they're going to care about it in a couple of years for X or Y or Z reason. So I'll be working on those things. And then when the time comes, I'm like, all right, I was right, or I was wrong. I don't know. That's the whole part of it.
Are you going to teach for us one day?
I would like to. I'm actually preparing a course that once it's ready, I will propose it, saying I want to go teach this. I don't want to go teach something. I want to go teach something specific that I want, that I'm passionate about.
Do you have any nuggets of wisdom? I feel like we've learned a lot about you and about how you became successful. Any nuggets for high school students?
Yeah, if there's one thing, strive for excellence. You will know if you're doing a so-so job, and you will be sincere with yourself, and you realize if you could do better. Just be completely honest to yourself, to nobody else, not to your parents, just to yourself. And if you're honest to yourself and you realize I could do better, and you decide not to do better, then you're agreeing that you are not striving for excellence. You are being so-so. And you just don't, I think you should strive to do more. So strive for excellence, be the best that you can be. And it's not easy, one, and and it's not easy. And if you realize it's not easy, try to be around people who you admire, who you see that they strive for excellence. And just don't be afraid to ask for help. The worst thing that will happen is that somebody will say no, or they will ignore you. The best thing is that they will reach out and be happy and help you out. So if there's literally somebody that you admire, just go reach out. Literally send an email. If you happen to bump into them, just go talk to them. Don't be afraid about that, because I think the world is full of really, really fabulous, happy people who are willing to help other people out. If you really want to go strive for excellence, and don't be afraid to ask for help.
And if they ignore your email, keep knocking on their door.
Exactly. Because the worst case is they won't answer. Best case is that they will, and they can change your life.
So we really do appreciate your time, Juan.